All right, so we're going to continue talking about our conjugate. Our complex numbers, not conjugates, our complex numbers. And so here we have the following example of 4x squared y plus 25y. And it wants us to factor completely. So in order for me to factor this completely, you always start with the what again? Your greatest common factor. So you're going to always check, is there a GCF? And for this problem, is there a GCF? Yes, and it is y. So I'm dividing y out of each term. Okay, so when I divide y out of each term, I'm left with 4x squared plus 25. Okay, now it says to factor completely, right? So in order to factor completely, I have 4x squared plus 25. And if I look here, these are not difference of perfect squares, is it? No, it's a sum of perfect squares because I have a sum of two perfect squares. Do we see that? So anytime you have a sum of squares, it equals complex roots. It's going to equal a complex. Okay, anytime you have a sum of squares, it's going to be a complex. If this was 4x squared minus 25, it would be easy peasy. 2x minus 5, 2x plus 5, right? But this is a sum, and therefore I'm going to have complex roots. The fastest way to think about how to solve for these complex roots is to get your x by itself. So we're going to isolate x. So we want to get x alone. So if I want to get x alone, I'm taking the inside only. And I have 4x squared plus 25, and it's equaling 0. Why is it equaling 0? You're trying to get x alone, but you're looking for roots, right? You're looking for zeros. And so therefore, I'm going to set it equal to 0. What do you notice when I'm trying to get x by itself here? Well, the y is still here hanging out, waiting for us to finish the problem. So y is right here, hanging out, saying, okay, hurry up, finish. Let me get my remote and I can do this.
So how come 0? Because you put the x, right?
So it's a 0 because you're saying if this is a actual real 0, like a real root, that means it's set equal to 0. Your y is 0. But okay, is that better?
Yes.
Okay.
So how do we know when to set equal to 0?
Anytime you're factoring or looking for roots or zeros, it's setting it equal to 0. Because we use the quadratic formula, and the quadratic formula automatically finds our zeros. So you could do the quadratic formula here with b being 0, or you just subtract and divide. Okay, so technically you can use, I repeat, the quadratic formula at any given time with a quadratic. It is the catch-all. It will solve any quadratic with no hesitation. So this little guy right here, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, that guy right there works for every single quadratic. Every single quadratic. Okay? The rest are just shortcuts. Does that make sense? So instead of using the quadratic formula and going through all this, I'm just going to subtract 25. And I'm left with 4x squared equals negative 25. Divide by 4. And I'm left with x squared equals negative 25 divided by 4 and take their square root. So the square root of negative 25 over 4 is plus or minus 5/2 I. Why is there an I there? There's a negative in the root, a square root. Huh? Yes, you should get x by its self.
And it's 5 over 2i.
It's 5/2 I. Plus or minus 5/2 I. Or you write 5i over 2. However you want it. Wherever you put your coefficient, the I, it doesn't matter if it's in the front or in the numerator. Okay. So now you have your zeros. So we got x alone fit our zeros. And then the third thing is to write it in factored form. My pen did that, not me.
Oh, yeah, totally. Yes,
Factored form. So factored form is, what was our first factor that we found? Our first factor was
Why?
y, our GCF. So that's going to be our first factor we write. Your GCF is a factor, right? And now I'm going to write my factors of my zeros. So we have x plus 5/2 I, meant 5/2 I, and then x minus 5/2 I. And that is your factored form.
No, it seems very necessary.
That is.
Huh? Well, that depends on what you're trying to solve for. So some things are easier to analyze when they're in factored form, and some things are easier to analyze when they're not in factored form. That's just kind of where it falls.
Got it.
That's it.
So factoring basically is the plus and the minus.
So factoring is meaning that you are, do you understand what factors are?
Yeah.
So factors are two numbers that multiply to produce something, right? Those are your factors. So when you have a polynomial and you're putting it in factored form, you're asking what binomial, monomial, or trinomial multiplies to create this. So this is made up of a monomial times a binomial times a binomial, and it created 4x squared y plus 25y.
So why do we put the I there?
The i's are there because when we found our x's factored out to be a negative underneath the square root, and that's illegal.
Yeah.
Okay. All right.
We don't tolerate.
So here we go. We're going to